7, first of all, just the definitions. We start looking at these. Okay, so electric current is the flow of charge. We've already looked at that. Okay, so we're going to mark that as done. All right. Now, Ohm's law. Now, this is the interesting thing. Okay, so Ohm's law states, okay, that a constant temperature, and that's crucial, a constant temperature, V over I is a constant. And that doesn't apply all of the time. Okay, so it applies for what we call ohmic conductors, metals generally. Okay. Now, V over I means over constant. Okay, if you think about it, means that V over I is, the slope of V over I is always the same, which means it's a straight line. So effectively, okay, we'll go into this in more detail later, but we V against I, if Ohm's law is obeyed, it will be a straight line graph through the origin. So the potential difference, the energy supplied, divided by the current flowing is always a constant, and that constant is called the resistance. So Ohm's law states a constant temperature V over I is a constant. The constant we call the resistance R, okay, so that's where that follows through. So if R is equal to V over I, so constant, so it's effectively the same thing. And then we can define the ohm. We'll say there's a resistance of 1 ohm if you look at it, if there's a potential difference of 1 volt and a current of 1 amp flows between 2 points. That's what's explained there. So effectively, this you can get without putting in all the ones up here. So it's a little bit like the other ones, so just be aware of that as well. Okay, so there are your Ohm's law ones, right? Not too many definitions in current electricity, as you can see. Okay, the other page we're interested in is page 10, okay, which is the experiment we've just been looking at. Metallic conductor, constant temperature. So set up the experiment is shown. Okay, so remember what we do, so we're going to draw this quickly. Okay, so we have our potentiometer effectively. Okay, that varies the voltage. You have an ammeter. You have a coil. Okay, the coil is in water, so we say that, and across here we put in a voltmeter. Okay, so that's your circuit. So using the potentiometer, adjust the voltage and read V and I for a series of different values, draw a graph of current against voltage, a straight line graph through the origin, V proportional to I, Ohm's law is obeyed. So we're going to explain that now in detail. Okay, so let's take the easy version of Ohm's law. So I is V over R, the one that works the best for us. So I is equal to 1 over R times V, getting our two variables on their own, and that's in the form Y is equal to mx. C is 0, so remember C is 0, it's through the origin. As long as the resistance is constant, the slope is constant, that will become relevant later. Okay, and we get this. V is on the x-axis, I is on the y-axis, and the slope is 1 over R. So if you want to get R, you get the slope, and you get the reciprocal of the slope, because R will be 1 over M. Right? So that's that one. That's what we're doing today. No more. We'll be following on with these ones later. Done.